I'm going to explain to you the next project that we're going to be doing in class. This project is called the Copper Circle Project. What it involves is us taking copper and mixing with other elements or other compounds and watching it disappear, go somewhere else, and eventually return back to its original form of copper. Now what we're going to be doing in step one is we're going to take a piece of copper wire. That copper wire is going to be placed into nitric acid. Now the nitric acid is going to react with the copper so that you won't see the copper anymore, you'll see something else. Now for reaction 2, we're going to take the same liquid and now we're going to add sodium hydroxide. The sodium hydroxide will carry out another reaction with the copper and it'll continue on the system. While we are doing reaction 2, you're going to get two containers. You're going to get sodium nitrate and copper 2, or you're going to have two products, sodium nitrate and copper 2 hydroxide. What we are going to be doing with this is we're going to be placing it in a hot water bath. The hot water bath helps the reaction to occur. We're going to add 2 mLs of water to our existing test tube to help make it so that we can separate the stuff that doesn't get involved in the reaction. Now, so you will see a color change or something else here. You will see a reaction going from here to there. Now, to get into step 4, we are going to be placing that same test tube, we're going to remove it from the hot water bath and we're going to put it in a cold water bath. Now the cold water bath is going to also add to the reaction. Now I've got 3 things that we're doing in the cold water bath. The first thing is we're going to obviously put the test tube in a beaker with some ice water. Then we're going to remove the top liquid layer. That top liquid layer may have something to do with this that we did over here in part 2 or part 3. After we've removed most of the clear liquid off the top, we should have most of our product sitting at the bottom. That product has copper in it. Next, we're going to add sulfuric acid to this reaction. After we've done that and the reaction occurs, you'll have one last step. You will take this product and you're going to add zinc to it. For step 5, as you add pieces of zinc, which is a metal, to your test tube, what you will see is copper reforming. Now the copper is not going to look like this. It should look more like little pieces of copper sitting at the bottom. All right, so that's an overview of the project. Now, during the project, you will be using the same test tube the entire time. You'll also be monitoring and writing down the types of reactions that are occurring under each of the 5 steps. I'm going to help you with step 1. All right, so step 1, it says write a word equation for each step. Solid copper reacts with nitric acid to form copper 2 nitrate, water, and nitrogen dioxide. That's my sentence. Now I'm going to write it as a word equation. So here's my word equation. Solid copper plus nitric acid to form, which means I draw an arrow, copper 2 nitrate and water and nitrogen dioxide gas. I ran out of room. I should be writing nitrogen dioxide gas. I have to write a balanced chemical equation with the state of matter for this. So here we go. Copper is a solid. Added to nitric acid, HNO3. Now, nitric acid is a liquid, and therefore I need to have an L over here. This reacts to form copper 2 nitrate. Copper 2 means it's Cu plus 2. Nitrate is NO3 minus. And water and NO2. So there's my equation. It's not balanced yet. Now this equation is very difficult to balance for most students, so I'm going to start balancing it for you. I'm going to put a 4 right here. Now you may ask, why am I doing that? Well, like I said, this equation is quite complicated, and I've done this a number of times. I know there's a 4 there. If I have a 4 here, I've got 4 H's. How many H's do I have on this side? I've only got 2. So I'm going to come over here and put a 2 there. So now I have 4 H's here and 4 H's there. Next, I look at my coppers. They're already balanced. Finally, I'm going to look at my nitrogens. I've got 4 nitrogens here. I've got 2 nitrogens there, 2 right there, and I've got 1 right there. So I'm going to put a 2 over here. So now I have 2 nitrogens there, 2 over here, so that's a total of 4 on the right side, and I've got 4 on the left side. Finally, I'm going to check my oxygens. I've got 4 times 3 is 12 oxygens here. I've got 2 times 3 is 6 oxygens there. And I've got 2 right there. And I've got 2 times 2 is 4. So when I add up all of these, I have 12. And on this side, I had 4 times 3 equals 12. Now, let me erase this, and we'll keep going. There's my balanced equation. I've done part 1, part 2, and now I have to write the type of reaction. Well, what you notice here is we've got copper coming in, and it's replacing something, and then something else is happening too. We've got to start off with two reactants, and we end up with 3 products. So this type of reaction is complicated. This is a single replacement. But you notice something else happened. Something broke apart. So it's also a decomposition. So now I've done the first 3 parts of the requirement for step 1 of the reaction. Remember, I am doing this just for this first reaction going from here to here. Now let's continue on. I have to draw I have to make a submicroscopic drawing for this reaction. So here we go. What I've done up at the top is I've made a table or a legend explaining which elements or what colors I'm going to use and symbols I will use for each of the elements involved. All right, so I've got copper here. Here's my balanced equation. And for copper, how many coppers do I have? I've only got 1, so I'm just going to draw 1 box here. How many coppers do I have on this side? I have 1 over here. Now I go to the next part. Hydrogens and NO3. N is my triangle. And I've got 4 of these. Running out of room. NO3, so I got to put 3 O's. Showing that these 3 oxygens are connected to that hydrogen, or to that nitrogen, and now I'm going to finally put my black dot somewhere else. and it could be over here. As long as you show what you're doing correctly, you should be in good shape. Now, if you choose to use a different symbol instead of circles and triangles, you can always make squares and other things. It doesn't really matter. So I've got 4 nitric acids. This plus 4 of these will equal 1 of those. And you see I've got an NO3 over here. How many of them are there? There are 2 of them, so I'm going to draw 2 of them. Here's my first one. I'm just going to draw it upside down so it's easier to see. And there are 2 of them connected to this. And each NO3, or each one, has 3 oxygens. The next step I'm going to do, and that's because there's 1 N right there and 6 O's. 1, 2, 3, 4, 5, 6. I'm not that concerned about where you put your oxygens and your nitrogens. I just want to make sure you understand that this compound is consisted of these guys. I've got to draw 2 waters. So my oxygen, I've got 2 of them, and now I'm going to draw my hydrogens for each one. Finally, I've got to draw 2 nitrogens on the end. And these 2 nitrogens are bonded with 2 oxygens. Now, to make sure I'm correct, what I'm going to do is I'm going to add everything up and see if it works out. How many blue dots do I have on this side? 3, 6, 9, 12. On this side, I've got 3, 6, 7, 8, 9, 10, 11, 12. I've got 4 green triangles on this side. I've got 4 green triangles on this side. And finally, there's my copper. So this copper that was in the wire is now in this compound. That's the second step, or that's the 4th step. And this is what you will need to do for each of the balanced equations that you write. I would recommend keeping the same symbols the entire time throughout the entire project. Number 5, evidence of a chemical reaction. During this time, you have to show me some evidence of a chemical reaction. I like a picture. Since this is a project, there's going to be visuals. So what I've done is I placed my wire in here. Here's my wire. And this over here is my HNO3. Well, what's happening in this intermediate picture is you see something occurring. And if you see bubbles or you see something else, that's some of the evidence. So in this first one, I'm going to say the evidence is bubbles. Finally, I'd like you to take an infrared thermometer and measure the temperature of the tube. You should measure it before and measure it after. You're measuring to see if the temperature has changed between the tube here and here. Some people just put their hands on it and they feel it. Other people like to use a thermometer. I would like you guys to use a thermometer aimed at the outside on both sides, and you just click on it and measure the temperature before and after. All right, so that ends the copper circle project, once again, just to make sure we're clear, there are 5 steps. You will start with copper, and when you are done, you should end with copper. This is a great project. There's a lot of chemistry involved. Remember, each step, you have to write a balanced equation, you have to write a word equation, you have to draw a make a submicroscopic drawing of the balanced equation, and finally, you need to write down the evidence of a chemical reaction. So in the first one, I said that there was bubbles and maybe a little bit of heat. The second one, maybe it's something else. Remember, evidence of a chemical reaction could be a precipitate forming, formation of bubbles, a new product, color change, something like that. Good luck.